Hey, what's up, kids? Mr. Murray here, Mr. Murray's Mathland, and we're looking at another Law of Cosines video here today. And we're talking about solving triangles for the missing sides, missing angles. Generally, people think of Law of Sines, Law of Cosines, and both good, both have their pros and cons. But take a look at this problem here. We are given three sides, and we are given that side A, which would be across from angle A. That would be right here, is 18. Side B, which is across from angle B, wherever you put it. I mean, I just drew a generic triangle here. Is 41. And side C, which would be across from angle C, is 27. Notice you are given three sides, so that is a congruence postulate, so there is only one way to construct a triangle with these three sides. So you know that this is not an ambiguous case. There's only one triangle potentially to solve for, and these three sides do satisfy the triangle inequality. 18 plus 27 is 45, and that is greater than the third side of 41. So you know it is actually possible to construct a triangle with these three sides. Okay, now let's just jump in. This is the side case, and this is a case where you pretty much have to use law of cosines, because if you're looking to use law of sines, you don't have an angle side pair. You've got three sides, but you don't have a single angle, across from whatever side you want. So side, and side angle side are really the two times when you will be using law of cosines here for side, or side angle side. And here is the law of cosines here. I've written out the three variations of it, and they're all the same idea that notice when you set this up, it's whatever angle you're interested in, that's the side that is isolated on the other side of the equation. So, side a squared is equal to the other two sides, b squared plus c squared minus 2 times those same two sides cosine of a. And it's the same pattern for all of these. It's the same thing, just changing the letters around. Angle b is here, side b is here. And a and c were used there. Side c, angle c. And that's a and b are used here on that side. Okay, so in case you have to memorize them for your tests, it's not too bad. Okay, so now when you have this, you're really free to find any angle you want. Law of cosines will work no matter what. But if you have been paying attention to a couple other issues that have popped up in our class or in a previous video, a lot of times after people find that first angle, say I find angle C first, then I'll have an angle side pair of C and C, and a lot of people will use law of sines to finish off the problem, and that's perfectly fine. If you just remember in a previous video that I said, if you're solving this with law of sines, and then you want to find the smaller of the two remaining angles, and as long as you remember that, you'll be all good. But another thing you can do to safeguard against that is, if you're using the law of cosines and you have the option, why not find the largest angle right off the bat? Let's find the largest angle. And that way, if there's an if there's an obtuse angle in this triangle, law of cosines will find it right off the bat. And then I know the other two must be acute, because you can't have more than one obtuse angle. So that largest angle would be across from the largest side. So that would be angle B. So I'm going to find angle B. And here we go. So that would be, side B would be the part that would be isolated. I'd be using that second variation of the equation. So I'd have 41 squared equals the other two sides, 18 and 27. 18 squared plus 27 squared minus 2 times 18 times 27 times cosine of my angle B that I'm trying to find. And so you could do a bunch of little calculations here and simplify, or you could, just manipulate and type it all into your calculator, which is what I'm going to do here. That if I really just subtract 18 squared from each side. Oh, sorry, I forgot to square that 27 there. Good catch. Minus 27 squared. And then I'm going to divide by this coefficient of the cosine of b. Just be careful, this is all one big coefficient. So if I divide by -2 times 18 times 27, and then I take the inverse cosine of all of that, that'll give you angle B, right? You're just moving these two to the other side, dividing by this coefficient, and then you have cosine of B. So take the inverse cosine of all of that. If you don't feel comfortable, take your time and, add these together, subtract them from that, divide by these two numbers, then take the inverse cosine of that decimal. No big deal, but when you're flying, it's kind of nice to be able to type it in one big step. So here we go, inverse cosine of, and you'd want to use some parentheses here for that entire numerator and a set of parentheses for that entire denominator, unless you want to simplify some things first. Or if you have a nice little fraction feature here, if you have a graphing calculator, you can kind of make it look just like it looks on paper. 41 squared minus 18 squared. And that's a really handy trick. Some scientific calculators have that option too, where you can make a nice fraction so you can not have to use extra parentheses all over the place. And so now let's hit enter. Let's see what our calculator gives us. And it does give us that angle B is about 130.25 degrees. So angle B is, in fact, obtuse, 130.25. 130.25 degrees. Okay, and I was in degree mode, which you want to be for these problems. Always make sure you're in the correct mode. So angle B is 130.25 degrees. And now you have an angle side pair. So like I had mentioned, it's up to you if you want to finish this off doing law of sines with your angle side pair, or you could just do what we just did to solve for angle B. You could use that manipulation to solve for angle A or angle C. And that's kind of nice because with the law of cosines, when you're doing inverse cosine, because of the restricted range of arc cosine being 0 to 180, if there's an obtuse angle, it'll give you obtuse. Arc sine, you have to sometimes consider the acute or the obtuse case. But I'm going to use law of sines because now I know I found the largest angle, and there's no more obtuse angles in here possibly, so I can find any angle I want. So I may as well go with angle A. And the sine of A over 18 is equal to the sine of B, which is 130.25 degrees divided by 41. I'm going to multiply by 18, and I'm going to take the inverse sine. Okay, and bring that calculator back in. And again, if you, I'm using that rounded answer, 130.25, to arrive at angle A. And if I want to make sure A is accurate to two places, I should probably use, go beyond two places there. I shouldn't use a rounded answer to obtain the new answer. So when I do this, 18 sine of 130 point, why don't I type a few more decimals? That's right above you on the screen, or you could use some store features with your calculator if you're good with that. You know how to use your memory. Divided by 41. And so that gives you angle A is about 19.58. And because I went so far beyond two places there, this answer should be accurate to two places. So angle A is about 19.58 degrees. And that makes sense that it's so small because side 18 was the smallest side. So smallest angle should be across from the smallest side. Whoop. And now let's find the last angle, which would be just adding these two together and subtracting from 180. Right now that you know two angles, 130.25 plus 19.58, 180 minus that, And you get angle C is 30.17 degrees. And notice that's kind of the medium-sized angle, and it's across from the medium-sized side. So all seems to be in order. And so there we go. That's the law of cosines for the side, side, side case. Again, my advice is if you're solving the side, side, side case, solve for the largest angle if you're using law of cosines. If you're using law of sines to find missing angles, find the smallest angle. And there you go, kids. Keep working hard. Let me know if you got any questions.